Hey guys, this video is called How to Make the Unit Circle Less Intimidating. All through school, I thought the unit circle was just this monstrosity that you had to memorize, and then trig functions were really confusing. I thought it was this huge list of things that you had to memorize, and I am not about that way of life. I want to be able to figure things out without memorizing them. And just a couple of years ago, I had this revelation of how the unit circle actually works, and I'm gonna teach it to you. Right? So what we're gonna do is we're gonna take all of this and make it to where you don't have to memorize it. You can figure it out. So let's start with the angle measurements. Here's my basic unit circle. I didn't want to do that yet. I know that once around the unit circle is 2 pi. Right? So far, that's really the only thing I've had to memorize. Once around the unit circle is 2 pi radians, which is the same thing as 360 degrees, which, by the way, gives you a nice conversion factor. If you ever need to convert from radians to degrees, you just got to know that once around the circle is 360 and 2 pi, same thing. If I cut 2 pi in half, I will get pi. If I cut pi in half, I'll get pi over 2. And now I'm going to count around by pi over 2's. I'm going to start at 0. Here's 1 pi over 2. Here's 2 pi over 2. You notice that 2 pi over 2 just reduces to be pi. Here's 3 pi over 2. And I come back around to 4 pi over 2, which reduces to 2 pi. If I cut pi over 2 in half, I get pi over 4. I'm going to count around the unit circle by pi over 4 now. Here's pi over 4, 2 pi over 4, which reduces to pi over 2. Here's 3 pi over 4, 4 pi over 4, which reduces to pi, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. Let me clean this up a little bit before we go on. Just leaving the major information. Okay, so I've got all my pi's, I've got my pi over 2's, and I've got my pi over 4's. Those are all settled. Now let's do the pi over 6's. I'm once again going to count around by pi over 6. Here's 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, sorry I'm running out of room here, and 11 pi over 6. Now wait, that's not quite what the unit circle looks like. That's because we reduce the fractions. Pi over 6 stays. This becomes pi over 3. This becomes 2 pi over 3. This one becomes 4 pi over 3. And this one becomes 5 pi over 3. But you see how I didn't have to figure out like which one's a pi over 6, which one's a pi over 3? You can count around by pi over 6's and then reduce the fraction, and you've got your pi over 3's. Not too bad, right? So, just to reiterate that, once around the circle is 2 pi, half of that is pi, half of that is pi over 2, count around by pi over 2's, so I have 1 pi over 2, 2 pi over 2, 3 pi over 2. count around by pi over 4s. So here's 0, 1 pi over 4, 2 pi over 4, 3 pi over 4. Wait, I messed that up. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and then count around by your pi over 6. There's 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over, oh no, not that one, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and just to check, come back around to 12 pi over 6. Alright, that takes care of all of your angles. Nice and convenient. Now let's zoom in and look at the first quadrant. So there's my pi over 2, here's pi over 4, pi over 6, and pi over 3. And what we want to do now is we want to label the coordinates for all of these. So I'm just setting up my brackets for my coordinates. The ones on the axis are fairly easy. I know my x-coordinate here is 1, my y-coordinate is 0, so the opposite's true over here. My x-coordinate is 0, my y-coordinate is 1. That's not so bad. Now in the middle here, everything's going to be over 2, and everything is going to be a square root. And then here's what's going to happen. It's going to go 3, 2, 1, 3, 2, 1. But what if I get confused on where my 3's and my 1's go? Here's all you've got to remember. 3 is greater than 1. If I look at this point right here, my x-coordinate is a lot bigger than my y-coordinate, so my x-coordinate must be 3, and my y-coordinate must be 1. And so here's how it goes. It goes 3, 2, 1, 3, 2, 1. Done. And it looks a little bit different than what you see because we don't show the square root of 1. I would just say that that's 1/2 square root of 3 over 2. And so when I'm thinking about things quickly, if it's a 45-degree angle, that's fairly easy to remember because they're both square root of 2. But when I think about pi over 3 versus pi over 6, I think what's bigger, my y-coordinate or my x-coordinate? If the x-coordinate is shorter, I know that's the 1/2. If the y-coordinate's bigger, I know that's the square root of 3 over 2. Now let's see how this maps to the second quadrant. If I have an xy point here, and I map it over to this quadrant, all I have to do is take the x-coordinate and make it negative, and my y-coordinate stays the same. So if this point right here was square root of 3 over 2 and 1/2, then this point over here is just negative square root of 3 over 2, 1/2. That also works for mapping a point down here. If I take this point, say square root of 2 over 2, square root of 2 over 2, and I map it down to the fourth quadrant, my x-coordinate stays the same, and my y-coordinate becomes negative. It's a little bit harder for me to think about mapping a point from here over here, but if you'll map it to either this quadrant or this quadrant, then it becomes much easier to make the jump here. So for example, if I wanted to map that 45-degree angle down to this 45-degree angle, first I mapped it down here. Now if I go from this point over here, I know that my y-coordinate stays the same, so that was negative square root of 2 over 2, and now my x-coordinate becomes negative. And it's done. So all you even have to quote-unquote memorize is your first quadrant, And then you can think about the rest of them. Now, what about trig functions? If I ask you to find the sine of, say, pi over 3, what I'm asking for is what's the y-coordinate at pi over 3? If I ask you for the cosine of pi over 3, I'm asking you what is the x-coordinate at pi over 3. And so, to answer either of those questions, I, in my head, do a quick sketch of the unit circle. I know that's pi over 6, so that one must be my pi over 3. My y-coordinate is bigger than my x-coordinate, so my sine is bigger, so that's the square root of 3 over 2. And my x-coordinate is smaller. Oh, that's a 3. So that must be 1/2. What if it asks you for tangent? I need to know my trig identities to make this easy. I know that tangent is sine over cosine. And so I think about my sine at pi over 3, which I know was square root of 3 over 2, over the cosine of pi over 3, which we just said was 1/2. I've got a fraction over a fraction, so I'm going to flip the bottom and multiply. And that gives me the square root of 3. I don't know the tangent of pi over 3 off the top of my head, but I can figure it out pretty fast if I just know that first quadrant, right? What if it asks you for, say, the secant of pi over 3? I don't have a clue. What I do know is that secant is 1 over cosine, aka the reciprocal. So if I take the reciprocal of the cosine of pi over 3 was 1/2. The reciprocal of that means I just flip it over, which means that the secant of pi over 3 is just 2 over 1, or 2. I could not tell you that off the top of my head, but I can figure it out very quickly. Cotangent works the same way. Cotangent of, say, pi over 3. I know that cotangent is 1 over tangent. If tangent is sine over cosine, then to find its reciprocal, I just flip these, which means that cotangent is cosine over sine. And so I find the cosine at pi over 3 over the sine of pi over 3, and I simplify. So I'm going to flip my bottom fraction and multiply. Those will cancel out. That gives me 1 over the square root of 3. If that's not an answer choice, I might rationalize it. And that's really all the trig that you need to know to be successful in calculus. You got to be comfortable with the unit circle, and you've got to be comfortable finding all of your 6 trig functions for any angle on the unit circle. I hope that was helpful.